Alrighty. So let's have a look at how does scale factor affect surface area. So in this case, you can see I've got two boxes. First one having dimensions 2, 3, and 1. The second one having the only one dimension given, which is the 4 centimeters. And we can see that the 4 centimeters matches with the 1 centimeter on this one. So the first thing I can work out is K, which is going to be image over original, which is going to be 4 over 1, which is just 4. Which means I can now work out the other two lengths, times by 4. 3 is going to become 12 centimeters, and the 2 centimeters over here times by 4 is going to give me 8 centimeters. Okay, so now I've worked out all of the dimensions of both prisms. Now the question is, how do we think it's going to affect the surface area of each of them? Well, our prediction should be that since area is scaled up by k squared, well, since surface area is basically the same but for a three-dimensional shape, that it should also be scaled up by a factor of k squared. That would be our hypothesis. Let's test it and see if it works. So, let's work out the surface area of the smaller prism. Well, it's going to be 2 times length times width for the front and back. And then it's going to be 2 more for the right and left. Plus it's going to be for top and bottom. Alrighty, so let's now work out each of them. So the dimensions of the front / the back is 3 by 2. The dimensions of the right and left are 1 by 2. And the top and the bottom is going to be 1 by 3. Which gives us a total area of the first one of 22 square centimeters. That's the prediction. So now let's try to predict what that's what we know. Now what we want to do is predict what we think the surface area of the other one should be. So the guess is that the image surface area is going to be equal to the original surface area times by k squared. That's the theory, which in this particular case is 22 times, scale factor is 4, so times 4 squared, which is equal to 352 square centimeters. And the question is, does this actually work? Because I'm guessing that it works, but let's actually double check. We think it should be 352. Let's see. Alrighty. So for this rectangle over here, let's do the surface area calculation for it. Well, once again, it's going to be 2LW plus 2LW plus 2LW. And in this case, it's going to be 2 times 12 times 8 plus 2 times 4 times 8 plus 2 times 12 by 4. And that's going to be our total surface area for the 6 different faces that are all rectangles. And we get exactly 352 square centimeters. So indeed, our theory is proven correct, that surface area can be calculated as either k squared is equal to the image surface area over the original surface area, and that the image surface area is equal to the original surface area times k squared. So basically we can treat surface area and area with the same rules. It's all to do with k squared. Alrighty, I'll see you in the next one. Goodbye.